Um, Hi everyone. Hi guys. I hope you're still doing well. So I don't know how I missed this, but this question said 5 seconds after the truck passes, and I missed that during the live video call, and none of you warned me. So you just watched me fail and you laughed at me. So you're mean people. But anyways, 5 seconds is what we missed, so that made our results weird. But thankfully, I was looking through the question again and I saw that. So it's always good to check your work. So everything else is the same. The truck is traveling at a constant speed of 20 through a school zone. After time t is equal to 0, he passes the hidden police car. So when they ask us to draw the graph, right? When they ask us to draw the graph, because it says sketch a graph that label the graphs of velocity of the truck. So I have 0 seconds, 10 seconds, 20 seconds, 30 seconds, 40 seconds, and I can have 10, 20, 30, and 40 for meters per second. So the truck is moving at a cool 20 meters per second velocity. Yeah, that's the truck. Make this line bigger. And the police car waits 5 seconds. 5 seconds after the truck passes, the police car begins moving. So the police car does not start moving at 0, it starts moving at 5, right? So 5 seconds later, it starts moving. And we had established that since it has an acceleration of 2 meters per second squared, right? 2 meters per second squared, then it doesn't, since it's not starting at 0, we don't know its y-intercept, so we can't just go from there. But if it's 2 meters per second squared, then that means that its velocity after 1 second, because remember, velocity is the change, acceleration is the change in velocity, v1 minus v0 divided by time. That's acceleration. So if I want to find velocity, if I rearrange this equation, I hope you remember it becomes v1 equals v0 plus acceleration times time. We also discussed it a few days ago in this expression here. Acceleration is equal to v1 equals v0 plus at. That's the equation I'm talking about. So I can find this object's velocity, the police car's velocity at any time. So let's see, after 1 second, its velocity will be, v0 will have been 0 because it started at rest, times acceleration, which is 2, times time, which is 1. After 10 seconds, it would be 0 plus, this was a plus 2 times 10. So after 10 seconds, that's 15, its speed is 20. That tells me that after 30 seconds, so v1 equals, so sorry about that, had to let it out. After 30 seconds, after 10 seconds, its speed was 20. After 20 seconds, its speed was 40. 20 seconds after it starts. So 20 seconds after it starts will be, let's see, 10, 20. So that's 25. Its speed is 40. Let me check this out. Its speed is 40. 40 is up here. So I can use those points to draw the graph of the, it's a big graph. I can use those points to draw the graph of the car, the police car. Let me draw it in blue. So that's the graph of the police car. Now the question they asked us first was, explain in a short sentence or two how you could use the graph you made in part A to determine the time, how will the positions of the car and truck compare when they have the same speed? We answered this. We said the police car is still behind the truck and it is increasing in speed, but it's still behind the truck when it has a speed of 20 meters per second. Because even if it reaches the speed of the truck, 20 meters per second, it needs to be moving faster to catch up or even overtake it. So it will still be behind the truck. So this is the part where we kind of got stuck. How would you use the graph to determine the time at which the truck and police are in the same location? So we know that when they're in the same location, they have traveled the same distance, right? And that distance is got by just determining the area under the graph. The problem we had was figuring out how to calculate that area, which the question didn't ask for. But we can still do it. We have time and we're young and all of those things. So all you would have to do is say, let's say they pass after some time t, right? After some time t. The area under the graph would have to be the same. So you wouldn't know what, sorry. So you'd find the area under the graph for this object and the area under the graph for the green object. How would you do that? Good question, people. Very good question. So for this graph, which I hope you realize I am introducing a question that's not part of the workbook, but it's still good. So I'm going to first find the area under the graph, and I'm assuming that this is T. I'll find the area under the green graph, area of the truck. I hope you can see the green graph is just this part, right? So its area will just be 20 times T. And that area has to be the same as the area of the car. The car has an area that is in blue. So the car's area is up there, right? Up to down here and then up to there. So it's a triangle. This is the police car. It's a triangle in which the area is a half times the base. The base is T. I hope you can see the base is from here. If this is T and this is 5, then the base is T minus 5. And the height of that triangle, we don't know. Right? We don't know what that speed will be, but we know that speed equals v naught plus 80. So we can find an expression for that speed. Since v naught is 0, a is 2, and time is just time, that final speed will be 2t. This might be confusing for you at the beginning, and like I said, I'm doing it, but it's not on the workbook. It's not part of that question. It's just a nice discussion point for us to be able to for real find out. So I'll have 20t on this side, and I'll have a half times t minus 5 times 2t, which I can take the 2 the other side, so I'll have 40t. I multiplied by 2 this side and 2 this side. I'll have 40t equals t minus 5 times 2t. 40t is equal to, if I multiply, I'll get 2t squared minus 10. So I have a quadratic equation, 2t squared minus 40t minus 10 is equal to 0. And if I divide by 2, I'll have t squared minus 20t minus 5 equals 0. You can solve this quadratically and get 2 answers, but you will only use the positive answer. That will be the time at which the police car catches up with the truck. Okay, like I said, that part of the question was not required, so I don't even know why I was trying to do it in the first place in that video call. But now you know. Now you know that it's doable. All right, Angela and Blake are discussing Carlos's graph of position as a function of time for the police car. And this is the graph. Angela says, since the police car is accelerating, the graph should be a curve, showing that speed is changing. The graph is correct. Blake says, I don't see how that can be. The police car waits for 5 seconds before moving, so the graph should not start at 0, but should start at 5. Which aspects of Angela's reasoning are correct? I'm just going to use green. Angela is correct that the car is accelerating. So we're just rewriting these things here, the ones that are correct. Angela is also correct that the graph should be a curve, because a curve represents changing speed on a position time graph. So that's another point to write here. Yes, it represents changing speed. But however, the graph is not entirely correct, because that graph should not start at 0 for the police car. It should start at 5. Right? This graph should not start at 0 seconds. it should instead start at 5 seconds. And that's what Blake says. So which aspects of Blake's reasoning are correct? Blake is right that the police car waits for 5 seconds. So the graph should not start at 0, but it should start at 5. And that's it. I hope it helps, and I hope you are able to listen through all of this background noise.